Hello, everybody. I'm very proud to present my talk there. This is a first step in series of my talk about distributed complexity. And before I start, I want to say who I am. I'm Maxim Danilov. I'm more than 27 years in commercial development. Last decade, I work with Python, Django, JavaScript, and also I am award-winning in like a mentor in engineering. Last year, I provide around 6,000 minutes in a year. It means around 20 minutes every day without a break for young Python developers for free. I'm like a volunteer. And yeah, yes, for this QR code, on this QR code, you can find link to slides or to whole repository about my talks on this conference. And the next step before I start, I want to say thank you for my family, my son Mark, my daughter Maya, my wife Elena, and Doc Marcel, Kat Kisa, probably they all you can meet Sunday in hall because they are present on this conference. And also I want to say thank you for my children. They create last 2 years all illustration for all my presentation. Thank you, Mark and Maya. And okay, what is complexity? What is it? In reality, I start to speak about really subjective things, because for somebody one code is complex, for me is completely not, and other case. And that's why all what I tell about complexity is subjective. It's not, we don't have any objective measurements or ideas what is complexity. And if we start to investigate or to research complexity types, in this case, we have structural complexity. Structural complexity, this is complexity which grows if we have more relationals between objects in our code. And we can remove or reduce structural complexity by changing the coding paradigm. Also, we have cognitive complexity. A pretty famous part of complexity exists as is for really subjective, because for me, something is easy, for somebody, something in code is really complex. Can be reduced a little bit if my team follow the strict coding paradigm or coding style guide, which should exist for every project, and it should be changed to business to implemented business goals in project. And accidental complexity happens as is. If we don't have a time, if we should to put something in production pretty fast, sometimes we find some compromises, and accidental complexity start to grow. And technical complexity, it's important, it should be, because technical complexity is our essential complexity. We solve the complex business task, and complexity from this task this is a technical complexity which should be implemented. It means it should not be reduced. We can frozen growing of complexity, but this complexity cannot be removed at all. Or yeah, you can delete all files and you can remove technical complexity. Yeah. Okay. The complexity every time grows with project. For example, we have complex business task. It's okay. It should be. We have complex task to make changes as fast as possible. And also, for every project, we have some missing knowledge about our project. On the start, it's probably one size. On the big legacy projects, there was 20 teams involved in development. Probably missing knowledge is already grew. Or already big lack of documentation, for example. And in matured project, of course, the complexity start to grow and mixed with other types of complexity, and we see we can obtain in matured project points of high complexity. For example, in some project, I open some file and I completely don't understand what is it, but it's my code. It's really complex to understand what happens there. And this is not a problem. It should be. But problem is if the complexity grows further. Because in this moment, the complexity start clash together, and we can see growth of structural complexity if complex business task increase, quantity of business task increase, and we should always put it in production. Structural complexity grows. Also, accidental complexity. It's exactly place there it happens. We have missing knowledge in our project, but we should push something to production. And we find some compromises. Don't matter what happens, we should simply update it, and accidental complexity have a high growth in this case. And of course, the cognitive complexity grows if we have complex business task and if we have lack of documentation. Welcome, cognitive complexity grows. But this is not a problem. Problem is here, vortex of doom. And vortex of doom is, it's not my invention. I like use this description of problem. It seems like we have issue to improve one bug, only one bug. Our developers working with this issue, improve the bug, send to production, and get 2 new bugs. And after that, we go to in the how it goes in cries and it's repeated, and consumes like a black hole full power of team. I have seen it one time in my life, and our decision on the we have decided around 100 bucks. We've frozen development and we do nothing more because every new changes increase the bug more than helpful. It was a really frustrated project, and probably I'm happy what I'm finished to work there. Okay, small recap. Complexity invented by humans. It's pretty subjective. Complexity is not the same as a touch depth. It's important. And complexity is not a bug, but can lead to bugs. And there is no way to keep complexity at low level, only if you don't work with this project anymore. If you freeze the project, okay, complexity not grows. Important is, if you start to manage complexity, it leads to better design of your project. This is really important. It means working about complexity is not refactoring. This is improvement of architecture in your project. And simplicity of code should be somehow documented or set it like KPI. This all in theory. Let's see how it works. Okay, measuring complexity. Count of code lines index. It's measure of the project size or globality of project. It shows us the cognitive complexity, how big it is. And I use my own measuring tool, dependency instructor. I show the output. Cons. It's this matrix is completely broken if you use black, the formatter by rough or prettier, because these linters or these formatters increase complexity automatically. And I completely don't understand why team use the short-time benefits like it seems all the same instead of instead of the long-term benefits. In this case, as many likes you have, as more complex project you have. And sometimes I meet different statements in one line. Okay, we can also measure it, how many lines use it. And sometimes I accepted it. Verbose code or long code can be more readable than a complex code, especially if I put it in one-liner with lambdas, generators, lists, and so on. Okay. For example, if we start to compare, DaVinci is commercial project, is around 1,000 lines in a project, summary lines of code around 50,000, max lines in one file is 2,000 lines, average 52 lines in a file, and we have a famous open source project. It's less files, it's around 900 files, but summary lines of code is 100, okay, right now it's probably already 200,000 lines of code. And max lines per file, 3,000 lines in one file. It's completely not readable, even for me, but I'm already works with big files. And average, we have 220 lines in a file. If we compare it with graph, you can see the DaVinci has strict style guide, which deprecated to write big functions, big classes, and to have many lines in code. And we have open source project there, not implemented strict style guide for contributors. And you can see in open source projects, of course, we have many code lines in a file. Thank you. And the next index. This index compares for us which art of paradigm you use, object-oriented programming or functional-based programming. This index also can show us got functions, big functions, or got classes with many methods and attributes. Subjective measurement, but it shows us cognitive complexity and, of course, structural complexity. I also use my own tool to measure. I show you the famous tools to measure it. Which problems we have this metrics? If your framework or code use full function compositions like Fast API, this is strange style, but this increase complexity if you use, for example, functional based style coding, and complexity grows if you use function compositions. And PyTest unit tests should not be counted for these metrics because, yeah, about testing, it's not code of our project. It's testing. Okay, for example, DaVinci commercial project has 3,000 functions, around 2,000 classes. And other side, we have famous open source project which presented themselves like object-oriented open source, but they have like 10,000 functions and only 2,000 classes. Okay, let's speak about oriented to open object-oriented programming in this repository. Okay, dependency index. Probably this is important part of our measurements because this is strictly shows for us coupling cohesion relations. I hope I should not describe what is it, but this is strictly measurement of structural complexity. I use again my own tool. You can find it on the GitHub or you can try it, but also you can find the official services which help us to measure it. Cons. Problem is if you use dynamic imports in Python or somehow import something on fly, this is a problem. Because dynamic imports I already show you open source projects. There they have billion dynamic imports, and I cannot measure which dependency index exists in this project. Okay, for example, my tool measure in business project, we have 1,000 dependency, only 24 libraries should be installed, and I use only 100 built-in dependency from Python, and framework, you can see, find around 900 dependency in between applications in project, and use more than 1,000 built-in dependency. It means it's really shows it is a framework which wrap and organize for us platform to build our application. Okay, measuring complexity official tools is in Sonar Cloud. We can find cognitive complexity. In repository from this talk, you can find the documentation how they measure cognitive complexity. Really subjective metrics, but yeah, you can use it. Cyclomatic complexity, to measure it, I strictly offer you to use Radon. This is Python library, and it's a perfect tool to measure cyclomatic complexity. Touch depth metrics you can find on CodeClimate resource. They also offer to use some subjective metrics about touch depth, and also composite code quality index by Codachi, but Codachi is built on Radon. In this case, this is extended version of Radon, results of Radon. Okay, for example, cognitive complexity is not the same like cyclomatic complexity. It's not too complex cyclomatically, but cognitive, it's high complex example. This is example from SonarCube. Okay, recap about measurement. All metrics subjective. And before to do anything, please use the collect some metrics. After refinements, please collect some metrics and don't forget to compare it. For example, you can find the article about Dropbox. We changed 3 million lines from the typeless lines to type hints lines. But which efficiency you get? Why you spend too much time? Many teams, many people to do it. There is the result. We don't have any answer, as is. Okay, and let's go to the strategy to how to reduce code complexity or distribute complexity. Refactoring. Refactoring. Every time I see, we should refactor it. We should refactor it. Oh, we need the whole refactoring. And this is exactly the numbers, how developers think about refactoring. Full refactoring for business apps recommended after 4 till 7 years. McKinsey research, updates with refactoring every 3 till 6 months, and full refactoring after the 5 till 8 years. Stripe report, developers spend around half time of work for refactoring. But stop, people, if after 4 years it came full refactoring, why you should spend time to refactor right now if in 4 years it will be refactored again? It means it was your time, the refactoring, the stupid refactoring. But I meet every day too much stupid refactoring. Sorry. Brief normally, I don't like it, but okay. And cast software report, if refactoring affected more than 25% from your whole code, please stop to do refactoring, simply write the new project at all. It's not my research. All links I provide in my talk or in the repository if I have PDF. Okay, but refactoring is not always a solution. Refactoring is convert all bugs and wrong decision in other bugs and other wrong decision at all. And let's go to the famous persons. Martin Fowler says, areas of high developer activity needs a zero tolerance attitude to tech debt. It's important. Somebody knows about high developer activity in your project. Somebody measure it. Somebody. Okay, let's see. Michael Fieser's offer to find places in our project there we have high developer activity. Info from virtual control system give a better sense of refactoring or developer activity. Okay, defining refactoring hot zones is pretty easy at first. Only few files change often, say Feasers. Some files must be clean from tech debt and ignore the rest, it says Fowler. Links to these articles I'll also provide in these slides on the last slide. Okay, we have also Pareto rule. 20% of changes affect on the 80% of results. And first refactoring steps should be done there. I write my own tool to find, I get the full repository log, and I find the file which changes regularly. Any other files simply not change it at all. It was created, it was tested, and finished work with that. Please find the files which change it regularly, and please keep your hands away from other part of your own project. That's all. And you can use it, zero tech debt zone, really easy to find, and you can compare the business project. We have less files which change it regularly, and famous open source project, they have bunch of files that's more than 300 or 400 files which change it regularly. It's okay, it's framework with big community, it's changed. And you can see also results. In business project we have around 4 commits in one file, and we have in framework it's around 100 commits per one file. Simply to compare it. Okay, refactoring recap. Refactoring is not a solution, but it can be a solution. Usually full refactoring happens in 5 years, and usually refactoring takes 40% of working time. And smart refactoring help us delay full refactoring for a time. If we change less files, complexity grows not too fast. Next. Next strategy to reduce complexity is increasing abstraction level. We can find the incredible article from Sandy Metz, Breaking the Behemoth. Somebody knows about it? It's amazing article, exactly about monolith, how we can refactor it. And Sandy shows us what, at start, we have simple functions. After that, we start implement new features, and simple function transforms in complex function. And to reduce complexity, we start transform complex function in a object-oriented abstraction with right implementation, I hope. And it's a little bit more complicated than simple function, but it's really much it's really less costly than complex function, and I can accept it. I see it many times. I transform from function which have around 1,000 lines in a class, split it by small methods, and it works amazing and readable. Okay, for example, you can see from previous result, we have around 40 classes in business project and 65% functions. And on the open source project, we have around 20% classes and around 80% functions. It means complexity in this framework is still not reduced. Okay, let's go. What we have else? Increasing modularity. This is probably the important part of this talk, because we start to speak about modular monolith. And Casey Hightower, this is a person, the first evangelist from Kubernetes, described this idea strictly many years ago. Organize your business logic as modular as possible, break it up across multiple repositories, keep those components as component. How it's possible? I show you. And you can get serious reduction in complexity, and you can simplify management process. I create my own tool which implement exactly these 4 steps. For example, we have some project in startup which grows, and we have 1 entry point, 2nd entry point, and we have also next entry point, and we can see some classes or libraries reuse it. Code can be reused from 1 entry point to other entry point. And the next step, we can see, we can take simply 1 entry point and collect all dependencies exactly for this entry point and put it separately. And other entry point also separately. If we can do it on fly, it means every time we work only with 1 entry point with small bunch of libraries and packages. Dependency instructor, which I create, do exactly this rule. You can see, I say, please, from project root, extract only 1 file. This file contains only 1 entry point. Example, DaVinci commercial project, I try to extract only 1 entry point from whole project. And famous open source project, I try to extract 1 entry point, like example. And you can see, in business project, I can find, for 1 entry point, I find 1,000 dependency. It's huge coupling. It should be refactored. And also, for 1 entry point in framework, we can see better situation with coupling, because only 900 dependencies find it. Okay. Important, I use IST-based parsing and collecting import nodes. In runtime, I don't have any coupling with the rest of the codebase. It means I improve stability of 1 entry point, and working entry point with all internal dependency, easily containerizable as standalone service, and it's possible to pack in more entry points in 1 container and run it. This is example. In source, we have 2,700 files, 750 folders, and 21 apps. As a result, we have 750 files, 250 folders, and 11 apps. High cohesion. 1 application in my project coupled with other 11 applications. It should be refactored. It's high complicated project, which, yeah, written not good. And also we have background for changes. If I have the listing of imported classes, I can see 1 class from my project imported many times, and probably this is a candidate to extract this class like installed dependency. Okay, increasing modularity recap. In this case, we do 0% of refactoring. We can run it run extracting exactly on the before creating the image for container. Okay, extracted model can be run at standalone and to isolate bug fixing. Extracted model can be run in monolith because it's still part of monolith. We have also reduced container image. We have reduced download time, faster testing, deploys, and cheaper if we use hosting on the cloud. And extract one procedure or one entry point can run it exactly before creation of Docker image. More about it, you can read in perfect article blog cycle from Camille Gritzbeck, Modular Monolith. I like this this part of Camille. It's pretty interesting. Okay, imports control. Oh, I like it. Yeah, imports control. Please, we have one famous rule, KISS. Keep import short. You can see from Django DB models fields import char field. What happens here? There. Why developers are at fields if I can write the same line from Django DB models import char field? Developers from Django specially organize all they use all in header model to offer for developer to use official interfaces. Now developers don't like it. They always find their own way. And also from Django, we have recommended art how we work with objects from Django. No, it's also skipped. Okay, the keys keep import short. Please don't forget about it. Deep nested logic. This is really example. API, domain errors, observation, domain models, observation. This is example how Java developers after 20 years of work came to Python. This is, yeah, structural complexity, high. Mental load, incredible, because I don't understand completely what means this chain. Okay, we have TDD, famous acronym. 3 dots deprecation. This rule should be in style guides. I know what means TDD in reality. Okay, and we can use linters like raf to control dot depth. Okay, we can also obtain complexity hotspots. If I find in one file 73 imports, can you imagine what happens in this file if we need more than 73 objects to work? I cannot imagine because I can keep in my head only 7 ± 2 objects. And this is a high complexity hotspots which should be refactored or minimum reviewed. What happens there? Okay, modularity recap. Control imports, it's control coupling in your project. Imports with many dots require more awareness about project. Incredible more. Avoiding short imports leads to fragile structure of your project. We can operate only with small count of objects concept, and many imports increase cognitive load. And refactoring imports usually don't need to be tested. It means you can refactor it without any testing. Okay, type hints. Oh, yeah. Okay, type hints. Blessing of course. If I see something like this, I think I see the winner of competition, the less readable code in the whole world. You can see we import some things only to get the types. It means we increase coupling only to use type hints. What's and in one time I think, what if I replace all type hints in project in typing any and remove unused imports? Simple as is. Okay, I do it, perform extraction, my own written tool. It's not exist now there because we have not too many crazy developers against type hints. And you can see Previously, I already showed find 560 dependencies, external dependencies. After the reducing type hints, we have only 500 dependencies. But important is, previously, we have 40,000 lines of code. After, we have 30,000 lines of code. You can simply imagine how complexity in your project reduced. It's like more than 20%. It's important. You can simply try it. But of course, somebody says, Max, but we have any alternatives? I like type hints. I don't know why. And at first, official way to use stub files. 0% refactoring. It means you can add typing in your zero typing project easily without any refactoring, simply to add the stub files. If you don't know what is it, please PEP 484 and read it. It's easy. Stub files don't create noise in code file. Any IDE or linter supported, and it can be creating stub files can be automated. It's important. I don't know why we improve something, invent something new if stub files exist shown many years. Okay. Also, we can use type hints in doc strings. For example, to generate auto documentation, we can put type hints in Sphinx styled docstring, and its IDE have supported it. It's collapsible. It means I can remove it from. I can collapse it in code and remove it from my eyes, and check can be automated. But if type hints required, if somebody in some cases, somebody use libraries which really use type hints for code generation in runtime, I created the typing decorator. They takes from stub files or from doc strings the description of types and add it on fly in class. For example, this is example. This is not data class. And we have one function. We don't have any typing, but we decorate it with typing decorator. And after that, we get the data class, and we have annotation for any function or classes. That's all. I don't have type hints, but I have type hints. Okay, type hints recap. Type hints increase cognitive and structural complexity. Type hints increase weight of package and code lines count. Stub file keep information about types, 0% refactoring in typeless project. Docstrings can keep information about types, and the typing decorator cover all cases, if type hints, of course, required. I have 5 slides. Sorry. Okay, documentation. How with documentation we can reduce complexity? At first, documentation should be written in style. If I die, all should works. I have not seen many documentation which written in this style. We should write unknown information in documentation, not the famous information in documentation. It means if I die, who knows the password from codebase, or who knows there I can get a password from codebase. And if we speak about security data, it should be written there I can get the required info. Okay, and you can also ask LLMs to add known information. They do it perfectly if it's important. But if this information is known, every developer, if he has a lack of documentation, can create this documentation on fly. That's why I'm not against LLMs for documentation, but unknown information should be written. Okay, let's speak about LLMs. Humans can operate the small count of concept. Nested logic can break understanding. Code readability is important for people's midbacks. And documentation should be near to code. And attention from developer affect on the quality of work? LLMs. Quantity of tokens, quantity of quality of tokens, and how cost is it? That's all. LLMs don't see any complex code. This is a problem. That's why AI can summarize statistically, perform reviews, add testing, collect and write known documentation, but they cannot understand complexity like humans do. Okay, please remember, complexity exists only in human minds, not in code. Final recap. Summary. Work with complexity leads to better design is important. Measure complexity. You cannot fix anything if you don't know complexity metrics. Please don't refactor before you get the complexity metrics. Smart refactoring is in a huge library is possible and wanted. We can isolate selected files and pack them into a separate package. Type hints increase complexity and coupling, and frequently important internal dependency. Extract, isolate, simplify, organize like external library. And you can try it yourself. Take a project, find zero-touch depth zone, like I showed previously. Get one file from this zone. Perform extraction for this file. You can use my library. Perform measurement. Apply some ideas from this presentation. Perform measurement again and enjoy. Probably it will be improved. Probably not. I don't know. Grazie mille, Bologna. Grazie mille, you, for attention. My name is Maxim Danilov. These slides by QR code contains useful links, contains software developer research, and I show the last slide only if you ask about it.
Okay, thank you. Thank you for your interesting presentation. We have a couple of questions, but we have last time, so I try to answer two questions. Okay, the first is, what's the famous project, open source project?
Sorry, simply go to my repository, the answer is there.
Then, second one was relative imports, goods or bads?
Don't matter. If you have an import, already complexity grows.
Okay.
That's all.
Because you are so quick to answer, I pose you the next question was, do you consider the refactoring process as a good way of managing project complexity if we analyze the issues we want to fix carefully?
Usually, I don't have any issue about complexity. I have issue about bugs. To decide to work with complexity, should the project owner, if he says the metrics goes down, for example, performance metrics from team. How to measure performance from developer team, I also report from Stripe, I put in repository.
Okay, thank you again. That's all. Thank you.
Thank you.